Yo, what's going on guys, Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. So in this video tutorial we're going to be talking about the implementation part of circular linked list. So this is the part 2 of the circular linked list topic. And before we start off, if you have missed the previous video tutorial wherein we discussed the algorithm and the concept of circular linked list, and we also saw our approach and what happens behind the scenes and the individual operations. So I would highly recommend that you watch that video because then you'll get a very clear idea and then understanding this code will be very easy. Not that you have to compulsorily see it, you'll definitely understand this video also, even if you have not watched the part 1, because I will obviously be explaining you the entire code and you'll also see a set of diagrams and visual representations which will make things very easy. But if you watch the previous video, then your idea will be very clear. And in this video, what we're going to do is I've already directly written all the code, because if I go ahead and type it out, the video length becomes very lengthy and then it gets a bit boring at the end. So directly we'll jump to the explanation part because the algorithm and the theory we've already discussed. So with that being said, let's get started. Okay, so just like singly linked list and doubly linked list, we create a class node. By the way, we are using C++ programming and we are using the object-oriented concepts. So we've created a class node. In circular linked list, we have a key data member which uniquely identifies one particular node object. Then we have the data member which actually stores the data. And we also have a pointer which is of the same class node. So you can see node star and it points to the next node. Okay. So we don't have previous node over here in just like we have in doubly linked list. So circular linked list is pretty much similar to singly linked list with one major difference, that is the last node in the circular linked list points back to the first node or the head node. Okay, so that's the only major difference. Otherwise, pretty much this code is the same if you've seen singly linked list implementation. So yeah, this was the node class, pretty basic to understand, right? Don't worry guys, I'm going to be sharing all the code with you and you can see links in the video description to the official website wherein I have uploaded this code with the explanation. So you can go check that out. You can directly copy paste and use it yourself. So yeah, let's move ahead. The next class that we create is the circular linked list class, and the object of this class is actually going to have only one data member, which is going to be the head pointer. Again, the same type of node because this pointer is also going to point to an object of node class only. Okay. And then we have basic constructors. So initially when you create the object of circular linked list, the head pointer will be pointing to null. And this is from the previous code, so we just have to remove this. Now I'm including everything in the public section because I don't want to complicate the code. So this is the only one constructor, default constructor that we need. And then now we start off with the operations, that is the functions of circular linked list. We've already discussed the 6 operations that we're going to be implementing in the previous video. So we're going to be doing appendNode, we're going to be doing prependNode, we will do insertNodeAfter, we will do deleteNode, we will be printing the entire circular list. And then this one is node exist, which checks if a particular node exists in the linked list or not, because we are going to be needing it in other operations also. So we'll first start off with check if node exists. Now if you watch the singly linked list video or the doubly linked list, in fact, pretty much the idea is the same. We pass in the key of a particular node. So let's take a visual representation. Let's say we have 3 nodes, node N1, N2 and N3, as you can see in the diagram. So obviously the head node or the head pointer in the circular linked list object is going to be pointing to the first node N1. You can see it from the diagram, right? So now let's say we want to search for a particular node and let's say the key value that we pass in this method is 3. Now if you see the diagram, from the diagram you can see that N3 has the key value of 3, right? So diagrammatically now we can say that this node exists with key value 3 that we are passing, but how do we programmatically check it? So let's see how the function goes. So first things first, we create a temporary pointer, okay, of node type and assign null to it. Then we create one more pointer PTR of the same class node and we assign the head value to it. Now we can directly assign the head value because all these functions are inside this circular linked list class itself, and head is a data member of circular linked list, so we can directly access it over here. So whatever the address stored in the head pointer, basically head pointer is pointing to N1 from the diagram, that is now stored in this PTR pointer, right? Now we are using this PTR to iterate through the entire circular linked list and you'll see how we do that. So the first condition is if ptr equal to null. So when will ptr be equal to null? When the head value will be equal to null, and head value will be equal to null only when there are no nodes in the list, right? So if there were no nodes, ptr would be null. But right now you can see that ptr and head both are pointing to n1, which means it is not null, it is having some actual address. So this if part is never going to be executed unless the entire circular linked list is empty. So the else part is going to be executed. Now inside this else part, we are using a do while loop. So you'll understand why we use a do while loop, okay? Let me just explain why we are using do while loop and not a while loop or any other loops. So let's get inside the do while loop, because the else part is executed, and do while loop, obviously we know that it executes for the first time before the condition is being checked, right? So it's a exit controlled loop wherein the condition is checked at the end, not at the start. So obviously the first time it is obviously going to run. So inside the loop, what we are checking is if ptr of key equal to k. Now the k value that we passed, we are assuming that we passed 3, which is the key value of n3. Our ptr right now is pointing to n1. Now n1 of key is, you can see from the diagram, is 1. So we are checking if n1's key is equal to what key we've passed, and we know that 1 is not equal to 3. So this if part is not going to be executed. So coming outside this if part, we are saying ptr is equal to ptr of next. So ptr right now is pointing to n1. So n1 of next is n2. So n2's address is now assigned to ptr. Okay, so you can see how we are traversing now. So now ptr is pointing to n2. And now the do while condition is checked over here, and it is checked as ptr not equal to head. Now remember, this is a circular linked list, right? So the last node is actually pointing to the first node, which means n3's next pointer has the address of n1 itself, right? Because we have to complete that circular loop. So that is what we are checking over here, that whether the ptr is actually the head address or not. Because if ptr is equal to head address, it means that we've arrived at the head again throughout by iterating the entire list, right? So right now ptr is pointing at n2. Now n2 is not equal to head, right? Head is n1. So again this do while loop will be executed. Now here we are again checking if ptr of key equals to k. Right now ptr is pointing to n2. n2's key is 2 from the diagram. 2 is not equal to 3. 3 is what we've passed over here, right? So again this if block will not be executed. Now we are saying ptr is equal to ptr of next. So now ptr will point to n3. Now again condition is checked. Is ptr equal to head? No, right? ptr is right now pointing to n3. Our head is n1. So again this do while loop will be executed. Now in this case, now ptr is pointing to n3. Now the key will be matched. So the address, that is the address of n3, which is stored in ptr, will now be stored in temp, right? At the end, now ptr will get incremented over here. ptr is equal to ptr of next. Now remember I told you n3's next is pointing to n1 only to complete the loop. So now n1's address is again stored in ptr. Now n1 is head. So here the match will be found and this do while loop will be exited, and we will return this temp. Now temp value has the address of ptr, which was pointing to n3, right? So this is why our method node exists returns a pointer of node class. So what we are returning is this temp pointer, which is obviously a node pointer, and right now it is pointing to n3. So coming to why we used do while loop. Now if we would have kept while loop over here, what would have happened is first the condition would be checked, right? So let's try to actually again dry run this entire code. I'm just gonna copy this and then I'm gonna comment this out, and here I'm pasting the while loop. So what I'll do is I'll cut this, paste it over here. Okay, and now let's try to again dry run the same code. Again we'll pass 3 only, right? So what will happen? A temp node will be created. We will assign null to it initially. ptr will store the address of head. So right now head is pointing to n1. So n1's address is stored in ptr. Again we check if ptr equal to null. Obviously ptr is not null. So this if part will only be executed when the list is empty. So now we are going inside the else part. So now if we check here, while ptr not equal to head, first the condition is being checked. Now if you see, we have assigned head value, that is the address stored in head, which is of n1. We have assigned that same address to ptr, which means initially ptr always points to head. So this while loop will never be executed, right? Because at the start only, the condition is ptr not equal to head. We are saying while ptr is not equal to head, only then execute the while loop. But ptr is equal to head only initially. So this while loop will never be executed, right? So we will never iterate through the entire circular linked list, and directly we will say return temp, and return temp is actually storing null. So every time we will get null value. Even though we know that there exists a node having the key of 3, this while loop will not execute, and then the match will never be found, and then temp will never have the ptr address, the current ptr address of n3. So this is why we have to use the do while loop. I hope you've understood, and I also tried to show you the visual representation. So yeah, this was the node exist method. Now the reason why we're returning a pointer is because we will use it in other functions, other operations. So let's move ahead and see the next operation, which is append node. So this method doesn't have a return type because we will be passing a node by address. So I hope you know the concept of pass by address. If not, I have a proper clear video on pass by address, pass by reference, and pass by value. I'll drop the link, or you can also see a card. So the new node that we want to append, now append always happens at the end, right? So if we already have 3 nodes, the new node that we pass will be appended at the end. Okay. So let's see the conditions. So first things first, we check if the node exists. So whatever new node we pass, it will also have a key value. So we'll have to first check if there is any other node inside the circular linked list with the same key value, right? And if it has, then we will say node already exists with the key value. So that's why we use this node exist method that we just created to check whether the node already exists with the same key value or not. Because we don't want any new nodes with duplicate or same key values, right? We want the key value to be unique. So this if condition first checks for that. Now if there is no match, we will get a null return value from this node exist method, right? So then the else part will be executed. Now in the else part, we are saying first we check if there are any actual nodes in the circular linked list. If there are no nodes, then head will be null. So this is where we check if there are actually any nodes in the circular linked list or not, because initially obviously we will not have any nodes in the circular linked list. So this condition checks if head equal to null. Now if it is equal to null, which means head pointer is having null value, so we directly attach this new node as the head value only. So now the head pointer inside the circular linked list object will be pointing to this new node, which is basically going to be the first node, right? And also remember that since this is a circular linked list, this new node which just attached as the head is also the last node, because we only have one circular linked list node right now. So the next value or next pointer of the new node will point back to itself, right? For the first time, because it is only the first and the last node. So that's why we are making it point to head again. So it will store its own address basically. And we say node appended at the first head position because it is the very first node in the circular linked list. However, if the head is not equal to null, which means that we already have some nodes in the circular linked list, in that case we have to again traverse till the end, right? So let's assume we have 3 nodes, n1, n2 and n3, you can see in the diagram. So in that case, again we take the use of a ptr pointer variable. We store the head address inside this ptr, and then we say while ptr of next not equals to head, and we traverse till the end. So when I say ptr of next, so let's say ptr and head right now is pointing to n1, because whatever address was there in head we stored in ptr. So both ptr and head are pointing to n1. Now we are saying while ptr of next not equal to head. So ptr of next is n2. n2 is not equal to head, right? So in that case we are saying ptr is equal to ptr of next. So now ptr will point to n2. n2's address will be stored in ptr. And this while loop will execute till we reach the end. So when we reach n3, when ptr is pointing n3, we will say ptr of next, which is n3 of next, equal to head, right? Because n3 is pointing back to n1. So we've reached at the end of the circular linked list, and this is the condition, that is ptr of next not equals to head. So when it will be equal to head, this while loop will stop and we will basically have arrived at the end, because now ptr will be pointing to n3. And now we have to append this new node n4 after n3, right? Because appending happens at the end. So now we say ptr of next, that is n3 of next, equals to this new node, let's say n4. We also have to say new node of next equals to head, because now n4 will point back to the head, because n4 is the end now. That is the tail of the circular linked list. Okay, so these two lines do that function, and then we say node appended. So this was the append node to a list. Let's see what happens in prepend node. Now prepend node is basically attach a node at the start. So we first again take the node. The first if block is similar to append node because we first have to check whether there exists a particular node with the same key value as this new node that we want to prepend. So this if block is checking that. In the else part, what we're doing is we are taking the help of a node pointer. We are storing the address of head and we are traversing till the end. So this is the same thing that we did over here, but we are doing this for another purpose. You'll understand it. So let's say there are 3 nodes right now in the circular linked list. So PTR will be pointing to the head initially. Then using this while loop, we are iterating till the end. I just explained how this while loop works. So after this while loop completely executes, PTR will be pointing to N3, right? Now what I'm saying is PTR of next equals to new node. Now we want to prepend this new node, right? So if we have N1, N2 and N3, N1 is the currently assigned head, but when we say prepend, this new node will be attached before N1. So this new node N4 is actually going to be the new head, right? So the last node, which is N3, which is currently pointed by this PTR, has to point to this new node, right? So that's why we say PTR of next equals to new node. So now N3 will point back to N4, okay? And not N1, because N4 is now the first head node. So this line does that. Then we say new node of next, that is N4 of next equals to head. Head is pointing to N1, right? Still we haven't changed the address inside the head. So now N4 will point to N1. And lastly we say head equals to new node. So now head address, that is the address inside the head pointer, will be changed to N4's address. So these are the steps we have to do in this particular order only. Otherwise the addresses will be mixed up and you'll not get the appropriate result. And now we can say node prepended. So this was the prepend node at the start. Now one modification inside the else part that you can do is, we've not mentioned if there are absolutely no nodes, what happens then, right? That condition was there in the append node. So this is that condition if head equal to null. So let's copy that. Inside this else part, we'll just paste it over here. And this all part goes over here in the second else. Okay. So we'll say node prepended over here. So that's a small change. And this was basically the prepend node method. Let's move to the next one. Insert node after a particular node in the list. So in this we require 2 parameters. First is the node after which we want to insert the node. So insert node happens at a particular location. Let's say we have N1, N2 and N3 in the circular linked list currently. So we can insert a node between N1 and N2 or N2 and N3 or at the end or at the start. But insert node after basically happens after a particular node. So obviously the start attachment is not going to happen. We will always insert a node after a particular node. So after N1 and before N2, or after N2 and before N3, or after N3, right? These are the places that we can attach a particular node. So first things first, we check if the node exists. But in this case, we are not using if else to check it. We are just storing the result of node exist and passing the key inside this pointer. So node exist method we created returns a pointer and returns an address if the node exists and returns null if it doesn't exist, right? That's how our node exist method works. So we will pass, let's say we will pass 3. Now we know in the diagram you can see N3 has the key value of 3 and this new node, let's say, is N4. So you have to attach N4 after N3. So this node exist will return the address of N3 which will be stored in the PTR. We will check if PTR equal to null. Obviously PTR will not be equal to null because N3 exists and we've just stored the address of N3 inside this PTR pointer. So in the else part, now again we have to check if node exists and now we are passing the key of this new node. So we first checked, or we first got the position where we want to insert the node. So right now the node has to be inserted after N3, which is basically at the end. But now we have to also check whether this new node's key doesn't match with any of the existing nodes in the circular linked list, right? So let's say if I pass N4 with a key of 3, we already have N3 with the same key, right? So we have to check for that. So that checking is happening in this if block. Now if it is unique, that is N4 has a unique key, let's say right now the key is 4, so it is unique. then the else part will be executed. Now in the else part, we have two more conditions. Either we will insert node at the end or we will insert node in between. So right now the condition is we have to insert node at the end, right? Because we passed the key of 3, n3 as the key of 3, and we have to insert n4 after this key, which means after n3, right? So how do we check whether the insertion is happening at the end or whether the insertion is happening in between? So this condition, ptr of next equal to head, will give us if the insertion is going to happen at the end. Why? Because right now if you see, ptr is pointing to n3, right? We got ptr pointing to n3 over here only, right? We passed 3 over here. We passed node exist key value of 3. Key value of 3 is only in n3. So n3's address is stored in ptr. So currently ptr is pointing to n3. Now we know right now ptr is the last node in the circular linked list. So obviously the next pointer of n3 is going to point back to n1. n1 is the head node. So this means we are at the end. So this condition, if ptr of next equal to head, is the condition to be checked when the insertion is happening at the end. So if this is true, we can say that the insertion is going to happen at the end. So we say new node of next equals to head. So n4 of next now points to n1, and ptr of next, that is n3 of next, now points to this new node. Okay, so that two linking are happen, and now we can say node inserted at the end. But if this is not true, that is if ptr of next not equals to head, let's say we pass 2 over here, which means we want to insert node after node n2 but before node n3, right? So in that case, ptr of next, that is n2 of next, is not going to be equal to head because n2 of next is going to be equal to n3. n3 is not the head. So in that case, what we do is we say new node of next, that is n4 of next, equal to ptr of next. ptr of next is n2 of next, which is n3. So n3's address is stored inside n4's next. So you can see from the diagram we are inserting n4 in between n2 and n3. So the first link is done from n4 to n3. Now we say ptr of next equals to new node, which means n2 of next equals to n4. So that linking is happening, and now we can say node inserted in between. Okay, so this was basically insert node after a particular node in the list. I hope diagrammatically things are getting cleared. Coming to the next one, we have delete node by unique key. So when we want to delete a node, we basically just delink it and not actually delete the object. And when we say delink, we just break the links which are there, or break the pointer address links. Okay, so you'll understand what's happening. We just pass the unique key because, as I mentioned, we will be uniquely addressing or uniquely identifying each node by its key value. So that's why we have the key data member in the node class, so that we can uniquely identify it. So let's see how delete node by key works, or delete or delink basically operation works. First things first, we will check if that node exists. So let's say we have n1, n2 and n3 with 1, 2 and 3 as the key values respectively. So if I pass 4 right now, that node doesn't exist. So ptr will be having null. So if that matches, that is if ptr is storing null, it means no node exists with the key value of k, which is something that you've passed. If there is a match, then ptr will be storing an address. Let's say you pass 3, n3 is having the key value of 3. So ptr will be pointing to n3. So in the else part, first things first, what we check is if head equal to null. Now this is just a extra redundant condition that I'm checking, because if ptr is not equal to null, it means that ptr is pointing to some node in the circular linked list, which basically means that head cannot be null, right? There has to be some values. So I'm just checking it just because I had to do it if else, and this is something that you can actually ignore it. So I'll just remove it and I'll start with this if condition only. So in the else part, we come in the else part when ptr is not equal to null, which means ptr is pointing to some node in the circular linked list that has this matching key of k, right? So first things first, we check if this ptr matches the head value. Let's say we have n1, n2 and n3. Right now you can see from the diagram, and key value of n1 is 1. So if we've passed 1 over here, ptr will be pointing to n1. Also the head pointer will also be pointing to n1. So this will be a match, right? So basically we want to delete the head node itself. So this is where we have to go inside this if block, this entire if block. Now inside this, what we have to do is we check if head of next equals to null. When will be head of next equals to 1? When there will be only one node inside the circular linked list, that is the head node, right? So in that case, we just assign null to the head pointer. So let's assume we only have one node n1 in the circular linked list. N1's key value is 1 and that is matching with what we are passing. So we want to delete the very single node inside the circular linked list. So in that case, we just make the head assign null and we say head node unlinked and list empty, because now head is pointing to null, which means there are no nodes in this circular linked list. Even though the object we did not delete, we just delinked it, right? We just removed the address and made it null. Now if head of next is not equal to null, which means we want to delete the head because PTR is matching the head address, but we have more than one node in the circular linked list. So we have the head node n1 and let's say we have n2 and n3 now. So then the else part is going to be executed. So in that case, what we do is we create a local PTR. So this PTR is only going to be existing inside this else block. Okay. So this PTR is different and this PTR is different. In fact, you know what? I'll just change the names if you are getting confused. I'll just make it PTR1. Okay. So I create one more pointer. I assign head address and now I traverse till the end by using the while loop concept. We've seen this 2 times now. Till the PTR of next doesn't match the head, we will keep on progressing. We will say PTR1 is equal to PTR1 of next. So initially PTR1 will be pointing to the head node, then it will be pointing to N2, then it will be pointing to N3, and N3 of next is the head node. So the while loop will exit and PTR1 will now be pointing to N3. So here we are seeing PTR1 of next is equal to head of next. So since we want to remove the head node, that is N1, the new node which is going to be the head node is going to be N2, right? And that is head of next. Right now head is pointing to N1, so head of next is N2. So head of next, that is N2's address, is now being stored in PTR1 of next. So PTR1 of next is basically N3 of next. So now you can see what is happening. Initially N3 was pointing to N1, now N3 is pointing to N2 because we want to eliminate N1. But head is still pointing to N1, so now we say head is equal to head of next. So head will now point to head of next is N2. So N2's address will now be stored in head and now head is pointing to N2. So now you can see we have completely delinked N1 from the circular linked list and the head object now is N2 and we will start from N2 only. Okay, so I hope you've understood this. Now these two things or these two aspects were only when we were getting the match of head, that is only when we want to delink the head object or head node itself. What if we don't want, or what if the node doesn't match the same that we pass over here? Let's say we have 3 nodes N1, N2 and N3 and we have 1, 2 and 3 as their respective key values, and if we pass 2 or 3 over here, so in that case the head node's key value, that is 1, is not going to match over here, right? So in that case this PTR, let's say we pass 3 over here, that is the last object. So PTR will be pointing to 3 now, N3, right? So it will not be equal to head. So this entire if block will not be executed. We will directly go into the else part. So in the else part now what we have to do is we have to traverse till N3 again. And we also have to keep a track of the previous node of N3. So basically now we want to eliminate N3. Let's assume. So I'm creating a temp pointer, I'm creating a previous pointer, and I'm creating a current pointer. So previous pointer is pointing to head, current pointer is pointing to head of next. In the condition I'm saying while current pointer not equal to null, inside this I'm saying if current pointer of key equal to k, then temp is equal to current pointer, and then I'm making current pointer null because you want to exit out of this while loop. Or else I'm saying previous pointer is equal to previous of next, current pointer is equal to current pointer of next. So what is exactly happening? Now this is a little bit confusing over here. Let's take the diagram. We have N1, N2 and N3. We want to delete or unlink N3. First things first, temp is equal to null. We are creating a temp pointer pointing or storing the address of null. We have previous pointer which is pointing to head. We have current pointer which is pointing to head of next, which means previous pointer is pointing to N1, current pointer is pointing to N2. Now if we've come till the else part, we already know that this if part did not get executed and we don't want to unlink the head node, which means we don't want to deal with N1, right? We've already declared or we've already arrived at that conclusion because if block is only when we want to delete the head node and if part is not executed and else part is executed, which means that we either want to delete n2 or n3. Now we've passed the key value of 3. Okay, so now we are having temp equals to null, previous pointer is pointing to n1, current pointer is pointing to n2, which is head of next. Now we are saying current pointer is not equal to null. Obviously current pointer is not equal to null because it is storing the address of n2. So for the first time while loop will be executed. Inside that we are checking current pointer of key equal to k. Current pointer is pointing to n2, n2's key is 2. The key that we passed k is 3. So this is not equal, right? So this if block will not be executed. We'll go in the else part. In the else part we are saying previous pointer equals to previous pointer of next. Previous pointer was pointing to head initially. So now head of next is n2. So n2's address is stored in previous pointer. Current pointer will store current pointer of next. Current pointer was pointing to n2, which is head of next. But now it will say n3. Okay. Again we will come at the start of this while loop. The condition is checked while current pointer not equal to null. We just said that the current pointer is pointing to n3. So it is having the address of n3, so it is not equal to null. So while loop will be executed. Inside this we are again checking current pointer of key equal to k. Now current pointer is pointing to n3. The key value of n3 is 3 and 3 is equal to k, which is 3 that we passed. So now the if block will be executed. In the if block we are saying temp is equal to current pointer. So temp will store n3's address and we are making current pointer as null. So we come out of this if block, else part is not going to be executed this time. And again we come to this while loop and now we are checking if current pointer not equal to null. But we just assigned current pointer as null. So now we will exit outside this while loop. Now from the diagram you can see the temp pointer is currently pointing to n3, right? And the previous pointer is pointing to n2, right? So now what we are saying is previous pointer of next, that is n2 of next, is equal to temp of next. Temp is pointing to n3. n3 of next is n1 because we have to complete the loop. So last node will be pointing to the first node. So temp of next is equal to n3 of next, which is equal to n1's address. So n1's address is now stored in previous pointer of next, that is n2 of next. So now n2 is pointing back to n1, which means we basically just delinked n3, right? So I hope you've understood. So this was when we delinked the last node. Let's quickly go ahead when we pass key value of 2. So when we pass key value of 2 over here, we want to delete n2. Again n2 is not the head node, then this if block is completely gonna be excluded, it will not be executed. We'll come to the else part. We will say temp is equal to null, previous pointer is equal to head, which is n1, current pointer is equal to head of next, which is n2. We'll check over here while current pointer not equal to null. Obviously current pointer is pointing to n2, so it is not null. In the if block we will check current pointer of key, that is n2 of key equal to k. K value we pass 2. The key value of n2 is also 2, so it's a match in the first run itself. We will assign that current pointer to temp. So now temp pointer is also pointing to n2. We will make current pointer as null. We will come out of if block, else block will not be executed. While loop will come to an end, and again when we check current pointer not equal to null, we've just made current pointer as null, right? So this while loop will be exited. So now as you can see from the diagram, the previous pointer is pointing to n1, the temp pointer is pointing to n2, right? So what we are saying, temp of next, that is n2 of next, which is n3. n3's address is now assigned to previous pointer of next. Previous pointer is n1. So n1 of next will store address of n3. And now you can see that n2 is delinked from the list. So next time we will jump from n1 to direct n3 because n1 of next now stores the address of n3. So this is basically the delete node by unique key operation. Last is update node by key. This is pretty basic. We just pass the unique key of the node and the new data. So I'll say new underscore data over here. Just copy this and change it over here. First we check if the node exists with this particular key. Let's say we have n1, n2 and n3, and if you see the keys 1, 2 and 3 respectively, if you pass 4, obviously that node is not going to be existing. So this method will return null. However, if you pass a particular key of a node which exists in the circular linked list, let's say 3, this PTR will point to that, and then we'll say if PTR not null, that is if PTR is pointing to a particular node in the circular linked list, we will access the data and change it to this new data that we pass over here. Okay. Else we'll say node doesn't exist. Pretty basic. The 7th one is just printing. We'll first check if head equal to null, and we'll say no node exists in the singly linked list. If head is not equal to null, we will simply do a do while loop. we will assign the head pointer's address to this temp pointer. We'll just print head address over here for verification, and then we'll say singly linked list values, and inside the do while we will say cout. We will print the key, we will print the data, and we will print the address of the next node, and then we have brackets and comma in between, and then we have this next node indication, and then we will say temp is equal to temp of next. And in the while condition, in the do while condition, we are checking if temp not equal to head. So obviously for the first time temp is equal to head, that's why we are using the do while loop again. Okay, so yeah, these were the 7 different methods. I have shared the entire code as I mentioned. You can check out that code in the video description on our official website. And in the int main, we are just creating a menu driven program just like what we did in singly linked list and doubly linked list. So I'm not gonna explain that again. It's just a iterative program. So it's a menu driven program, and the menu keeps on showing till we enter 0 to exit. In the switch case, we are calling individual methods. So this is something that we've been doing throughout like the last few videos. I'm pretty sure if you watched any of the video, this will be very clear. This is just us calling these methods that we just created in the class. Okay, so let's directly run this. I'm gonna say compile and run. Okay, I forgot a semicolon over here. I made a little bit of syntax error. Save this, execute, compile and run. Okay, so our program is running perfectly fine. So the menu driven program is saying what operation do you want to perform, select option number, enter 0 to exit. So let's first do a print operation. If I say 6, if I hit enter, I'm getting a message no node in the singly linked list because we have not really attached any of the node, and this has to be circular linked list. It's just a typo. Let me just correct that. Okay, so now I'm gonna say append node. If I hit 1, append node operation, I'm saying enter key and data of the node to be appended. So I'm saying key as 2, hit enter, and the data as 20, hit enter. So now I'm getting the message node appended at first head position because initially our circular linked list was empty. So let's clear the screen, hit 7 and hit 6, which is print. Now if I hit enter, I'm getting head address of this address value. Then I'm getting singly linked list values of 2, which is key, 20, which is data, and the address of the next node, which is basically pointing to the head node itself. So for the first node, that is the very first node in the singly linked list or circular linked list, we are getting the same address, right? Because it is pointing back to itself. And this is circular linked list, not singly linked list. I have not made the textual changes because I just copy pasted the code. Let me just change that. Okay, I'm appending a node. I'm saying 2, enter, and 20. Node appended at the first position. Let's do one more append. I'm gonna say 1. I'm gonna say 3 and 30, or let's do 4 and 40 actually. Let's clear the screen and let's print the list. So there you go. You can see now we have 2 nodes in the circular linked list, 220 and 440. So if you see the address in the next pointer of node N2, that is the node having key value of 4, it is the same address, that is the head address. So the head address is 0x1615b0. The next pointer storing the address is the same of the head node. So you can see the last node is pointing back to the first node. Let's do a prepend. So prepend would be something coming before 220, right? So I'm going to say option number 2, that is prepend. I'm going to enter the key of 1 and the value of 10, that is data of 10, hit enter. You can see I'm getting node prepended. So now let's see how the circular linked list looks like. It has to be 1 and 10 and then 220. So let's do print, that is option number 6, hit enter. So there you go. You can see now 1, 10, 2, 20 and 4, 40. So the new head is this 1, 10 node. And now the head address has changed to 0161AD0. And if you see in the last node, that same address is reflected. So the last node is pointing back to the first node. So this is that circular linked list pattern. So append node and prepend node is working. Let's do a insert node after. And we will insert node after 2, but before this 4. So let's hit 3. So enter the key of existing node after which you want to insert this new node. So you want to insert the node after 2. So I'm going to hit the key of 2. So it's saying enter key and data of the new node. So it's going to be 3 space 30. Hit enter. And there you go. You can see node inserted in between. So now let's do a print. I'm going to say 6. And now there you go. You can see 1, 10, 220. And now we have a 3 and 30 before 440. So we've successfully inserted this node N3 or 330 node between 220 and 440. Let's do an insert node after at the end. So select option number 3. We will insert after this node 4, right? So I'm gonna hit the key of 4. I'm gonna say 5,50. Hit enter, and now I'm getting node inserted at the end. So if I print the list by option number 6, there you go, 1, 2, 3, 4, and then we have 5,50, which is the newly added or newly inserted node. Let's do a delete node by key. Option number 4. Enter the key of the node to be deleted. I'm gonna hit 4 or 5. Let's delete the last node. Hit enter. So I'm getting node unlinked with key value 5. Let's print the circular linked list values, and now you can see I have 1, 2, 3, 4, but I don't have 5. Let's delete one more time. This time we will delete the third node. So I'm gonna pass the key of 3. Hit enter. I'm getting node unlinked with key value 3. Let's print, which is option number 6. So now I'm getting 1, 2 and directly 4. So the third node has been unlinked. Lastly, we have update node. I'm gonna hit 5. So it's saying enter key and new data to be updated. So let's update node having the key value of 4 with the new data of 110. Hit enter. We are getting node data updated successfully. Let's print the list, and there you go. You can see in the last node, which had the key value of 4, the new data is 110. Initially, if you see over here, it was 40. So yeah, pretty much all these methods are working perfectly fine, and this is the entire implementation of circular linked list. I hope you've understood this. If you watched the singly linked list and doubly linked list, this definitely must be very easy to understand. Of course, as I mentioned, everything is being shared in the video description, all the code and explanation. So yeah, this was the circular linked list, and thank you so much for watching. If you've made it so far, please subscribe if you haven't already. Share this video with your friends. Do give it a thumbs up, do give it a like, and let me know in the comments how this video was. So thanks for watching, guys. See you guys in the next one. Peace.